like structures. Each atom is surrounded by four nearest neighbors. In its crystalline structures, every silicon or germanium atom tends to share one of its four valence electrons with each of its four nearest neighbor atoms, and also to take share of one electron from such each neighbor. As the temperature increases, more thermal energy becomes available to these electrons, and some of these electrons may break away, becoming free electrons, contributing to conduction. The thermal energy efficiency ionizes only a few atoms in the crystalline lattice and creates vacancy in the bond. The neighborhood from which free electrons, which has a charge of -q, has come out leaves a vacancy with the effective charge of +q. The vacancy with the effective positive electronic charge is called a hole. The hole behaves as an apparent free particle with effective positive charge. In the intrinsic semiconductor, the number of free electrons, Ne, is equal to the number of holes, Nh. That is, Ne equals to Nh equals to Ni, where Ni is called intrinsic carrier concentration. The diagram shows schematic model of generation of hole at site 1 and the conduction electrons due to thermal energy at the moderate temperature. The free electrons move completely independently as the conduction electrons and gives rise to electron current, i.e., under an applied electric field. Remember that the motion of a hole is a convenient way of describing the actual motion of bound electrons. Whenever there is an empty bond anywhere in the crystal, under the action of electric field, these holes move toward negative potential, giving the hole current IH. The total current, I, is the sum of the electron current and the hole current, that is, I equals to IE plus IH. An intrinsic semiconductor will behave as an insulator at temperature T equals to 0 Kelvin. It is the thermal energy at the higher temperature, that is T greater than 0 Kelvin, which excites some electron from the valence band to the conduction band. These thermally excited electrons at T greater than 0 Kelvin partially occupies the conduction band.